Kia ora everyone and welcome back to the IA Max channel. I'm Ali Mahi here. In this video I'll be talking about user defined routes or UDRs, what are they and how to implement one. So let's dive in. Before we start to talk about how to implement Azure User Defined Routes or UDRs, we need to understand a bit about how routing is done using Microsoft Azure. So by default, when you create a virtual network or a VNet with subnets inside of it, Azure would create a routing table and populate it with the the whole address space of the VNet, so that you would be able to route to destinations within the network. So a normal routing table, after creating the VNet, you would have a route to a 10.0.0/16, which is the address space in our case, and also you would have a default route toward the internet. To understand more about the Azure routing table, let's examine in details the fields of a typical route table. So we've got the source, the state, the address prefix, and the next hop type. For the source, there are three possible values. It could be a default, a user, or a virtual network gateway. So the default is for the system routes, which are the routes that Azure automatically populates the routing table of a VNet as soon as you create the VNet. The naming default might be a bit confusing. It is not talking about default route as much as it is talking about the system routes. So a better name would be system routes. Still, it is called a default route, maybe because it's populated by Azure by default. The other type of sources of routing is what is called a user. This is for user-defined routes, which is what we are talking about in this video today. The third type of routes is a virtual network gateway. This is for routes that Azure learn through a BGP routing table. I'll talk about BGP routing table in a future video, or also from a VPN. For example, if you have a VPN or Azure VPN with your on-premises data center. So the routes that Azure learns through the VPN would also be called virtual network gateway. I'll also talk about VPNs in a future video. The next field is the state, and we have only two possible states. The first state is the active one, which means that this route is currently used by Azure. The invalid one, it just means that Azure is not using it. And there are multiple reasons, and we'll see why in this video. So there could be like a more specific route, or there is another route with higher priority. I'll talk about this in a minute. But invalid just means that Azure is not going to use this route when sending traffic towards a destination. Active means that this is the one that Azure is currently using. The address prefix is for the destinations that Azure knows about. So all the destinations that Azure will be able to route to will be listed under the address prefix. And then finally, the next hop type. So this is where Azure is going to send our traffic next. So if the next hop type is a virtual network, this means that the traffic will be routed within the VNet. It's not going to leave the VNet. If the next hop is the internet, it means it's going to be sent to the internet. If the next hop is a virtual appliance, this could be like a network virtual appliance. This could be a firewall, a router. This could route traffic outside our VNet or within our VNet, but still it's using what is called a network virtual appliance. And the last type is none. This is when you want to drop traffic. So if you want to make sure that traffic will not be leaving your VNet or something like that, so you put a route to a none. So if there's no more specific route, traffic toward this destination will be dropped. Earlier in this video, I talked about invalid routes, which means that Azure is not going to use this route. And there are a couple of reasons that Azure will not be using a route. For example, in this case, if there is a more specific route that exists in the routing table, Azure would always follow the more specific route to a destination. So in our example here, we've got three routes. One is a 10.0.0.0/8, and then /16, and then /24. And the next hop is A or B or C. By default, Azure would follow the more specific route toward a destination. So if I'm sending traffic to 10.0.0.1, Azure with Azure having three routes that could lead to 10.0.0.1, Azure would always follow the more specific one. So in this case, the more specific one is the /24. So Azure will send traffic to C. So C will be the active route in this case, and A and B will become invalid for this specific destination. The other rule that Azure would use to forward traffic is that if Azure knows about the same exact destination, all with the same prefix length, they are all with a /24 prefix, Azure would follow or would prefer a user-defined route over a BGP route, and would prefer BGP route over system route. So in our case here, if we want to send traffic to 10.0.0.1, and Azure knows about three possible routes to a destination, they are all the same length. Azure would prefer if there is a user-defined route, it would prefer the user-defined route first, and then would go to the virtual network gateway, which is the BGP route, and then finally it will use the system route. So in our case here, traffic will be sent to next hop A, and then A will become active, and B and C will become invalid. So why would we use a user-defined route or a static route, which is what is called in the networking world? We would use a UDR if you want to inform Azure about a new destination that it doesn't know about. So we would tell it that if you want to reach x.y.z, use this next hop as to reach this destination. So we use UDRs to add a new destination to our route table. The other reason is that if I wanted to force traffic to follow a specific path. So as we've seen in the previous slide, Azure would always prefer our user-defined routes or UDRs over any other source of route or any other source of information, routing information. So this way we could have the flexibility of changing the traffic path to suit our requirement. So as we'll see in this example, we've got a virtual network called VNet1, and we've got three subnets inside of it. One subnet is called public, the other private, and then in the middle we have a DMZ subnet. So for security concerns, let's say that we want to inspect all traffic flowing between the public and the private subnet. We want maybe to filter in the future traffic between the public and the private subnets. So by default, using system routes only, any resource, any VM or any other compute resource inside of a VNet will be able to directly talk to the other resource using the system routes by default. So to change that, we will create a UDR that will associate with the public subnet. So any traffic that would be sent to the private subnet should first go to the DMZ, and then another route or another route table associated with the private subnet, so that any traffic destined to the public subnet will go through the DMZ. So to go into details, this is how the route will look like. So of course the source will be user. In here, the address prefix, which is the destination. This is from the public subnet toward the private. So we are telling Azure that for any traffic that is destined to the 10.0.1.0/24, which is the private subnet, use the next hop as the type of a virtual appliance, which is the NVA here, Network Virtual Appliance. And of course, we need to specify the next hop IP address, which is the IP address of our machine here, 10.0.3.4. And from private to public, we'll have another route table with a route inside of it. The route would be telling Azure that for any traffic that is destined to the public subnet, which is 10.0.2.0/24, again, the next hop is a virtual appliance, and the next hop IP address is the 10.0.3.4. Now that we understand what is a user-defined route, let's jump in on the Azure portal and implement a user-defined route. Now that we are in the Azure portal, let's understand a bit about our scenario today. So we've got a VNet called VNet1, and inside VNet1 we've got 3 subnets. We've got the private subnet, the public subnet, and the DMZ subnet. The 4th subnet is called an Azure Bastion subnet. This is for a solution to help us securely remote desktop to a machine from within the Azure portal. I'll talk about what is the Azure Bastion in a future video. Let's look into our virtual machines. So we've got 3 virtual machines here. One is called a private VM, and the other is called a public VM, and the third is our NVA, Network Virtual Appliance. So under the hood, all these VMs are actually Windows 2019, and we are going to look into the default routing table or the system routing table that is associated with those VMs, and then we will change the traffic flow so that traffic between private and public VM would go through the NVA for our security requirements, so that will be, so in the future we could inspect all traffic or we could filter it. To check the routing table that is associated with a VM by default, so let's click on the VM, and then let's click on the networking tab under the VM on the left side. And then in here, let's click on the network interface attached to the VM. Under the network interface tab, click on the effective routes, and it's just going to take a second for Azure to to show us the route table. As you can see here, this is the routing table associated with a VNet. So by default, as you can see here, we've got the default route, which is active with a next hop of internet, sending any traffic for sending traffic to the internet. And also we've got a route to the whole address space of our VNet, which is 10.0.0/16, next hop of a virtual network, which means that traffic will be routed within the VNet. The other routes here, we could easily ignore. These are routes put to avoid some routing issues, so that we didn't send unwanted traffic to the internet. We could also check the routing table for the other virtual machine. Go back to the public VM, again networking, click on the network interface attached to the public VM, and then again go to effective routes. Just wait for a couple of seconds to show us the routing table. And again, as you can see here, we've got a default route toward the internet and then a route to the whole address space of the VNet. So what we want to see now is that we want to confirm that the current traffic between the VNets was actually being sent directly. So we will connect to both VNets and see how traffic is flowing between them. And then we'll try to change that using a UDR or a user-defined route. So let's go back to virtual machines, click on the private VM, and then under setting, click on the connect. Go to Bastion and then use Bastion. And then let's write in the username and the password. Connect. And then let's go to the public VM. Again, use Bastion. Connect. Bastion, use Bastion. And then again, the username and the password. And as we can see here, we have connected to the private VM, and this is the public VM. So let's open up CMD, and let's this is the private VM. Let's ping the public VM. And as you can see here, we are able to ping it. And now we'll use a command called traceroute, which shows us the hops that a traffic is following to reach a specific destination. So trace RT public VM. And as you can see, it's just one hop directly to the public VM. And from the public VM toward the private VM, again, let's open up the CMD, trace route, private VM, trace route, private VM. And as you can see here, this is the public VM is reaching the private VM with one hop. So now let's change that. We want to send traffic between those machines toward the network virtual appliance, which is our MVA. So to do that, we go back to the Azure portal and then look for route table. We need to create a route table. We'll first create a route table and we'll call it from public to private. So we'll choose our resource group here. Where is it located? And then we'll call it public to private. And then yes, leave it to propagate, review and create, and then create. Our route table is now ready. So let's go inside the route table and create a route. So click on under setting, click on routes, and then click on add. We'll call it to private, and then we'll put the IP address of our private subnet. And then in here, we're going to say the next hop type will pick the virtual appliance. And then we'll need to put the IP address of the virtual appliance, which I believe is 10.0.3.4. Yep. So we are ready to create the route here. So let's hit OK. Yeah, as you could see here, we've got our route here. So to associate this routing table with the public subnet, we go back to the virtual networks, to our VNet1, and then to the subnets, and then to the go to the public subnet, click on it, and in here you see there is a field called route table. Click here and associate the public to private route table that we just created, and then let's save it. Cool. So this should now have changed the routing table so that traffic between the public to private will be sent to the NVA. So let's test that. Let's go back to our public virtual machine and let's test traffic to see if it's going to go through the NVA. So trace RT private VM. So as you can see here, it actually is going, the first hop is going to the NVA, and then the next hop is going to the private VM. We didn't associate this route table with the private subnet. So traffic from the private subnet back to the public subnet here will still flow directly. It's not going to go through the NVA. So if we test it again here, we could see it is still going directly. So to change that, we need to create another routing table, and then this time we'll call it private to public. And then create. And then let's create a route to the public subnet from the private to public route table. Let's under the setting go to routes, and then add another route. And this time it's to the 10.0.2/24. Sorry. to public. This is the name of it. Next hop is the virtual appliance, and the same next hop IP address of the MVA. So now as our route is ready, we need to associate this routing table with the private subnet so that it would use it to send traffic to the MVA and then to the public subnet. So to do so, let's go back to virtual networks, again VNet 1, and then to subnets. This time we'll pick the private subnet. So let's click on the private subnet and associate the private to public route table this time. And then save it. And now let's test the traffic. So let's trace to our public VM. Trace RT public VM. So as you can see here now, it is taking 2 steps or 2 hops to actually reach the destination. So the traffic between the private to the public subnet is now going through the MVA, which is the desired behavior. The one last thing that I want to show you is the change that we did to the routing table. So if we go back to our virtual machines and then click on the networking tab, click on the network interface associated with the public VM, and then to the effective routes, we should see another route added to the private subnet with the source of a user. So as you can see here now, we've got the new route with a source of a user. The route is active. It's toward the 10.0.1/24, next hop of a virtual appliance, and with the next hop IP address of the MVA. And of course, in here, it is saying that I am using a route defined within the routing table of public to private. It is using a route called to private, which is the one that we created. And a similar setup will, of course, be associated with the private VM. I hope you found this video useful. And if you have any comments or questions, please leave them in the comments below. And as always, stay strong. Kia kaha. See ya.